So let's get started on our discussion about geometric series. So here's an example. Suppose you email a joke to 3 friends on Monday. So you are emailing to 3 friends on Monday. Okay? Each of those friends sends the joke on to 3 of their friends on Tuesday. Each person who receives the joke on Tuesday sends it to 3 more people on Wednesday, and so on. What would the common ratio be? 3. Good. What would the formula be for the nth term? You guys know this already. A to the n for a geometric sequence equals the first term multiplied by the common ratio raised to the power of n minus 1. Good. You guys remember that?
Yeah.
And that'll give you each term of your sequence, correct? So today we're going to learn how to add all those up together with a formula. So, how many total emails would be generated by Sunday? So let's look at this first. So it's actually n equals 8 because there's you that's sending the email, so the first jump would be on Monday, right? Does that make sense? This is like 0 if you think about it. Monday is when the magic occurs, right? So Monday, then Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So how many total emails will be generated by Sunday? So remember when we learned about arithmetic series? And we did that cool thing where I showed you this is the series, and then if you wrote the series in reverse, and then we added, right, and then we divided by 2, and that's how we came up with a to the 1 plus a to the n divided by 2 times how many there are, right? So check this out. Check out what happens when you're dealing with something that's being multiplied, not added. Take a look at that. So it's not just subtracting, it's multiplying by 3. You'll see in the formula. Okay, check this out. Are you guys ready? Because it's a geometric. It's multiplying, not adding. Okay? So, So if I multiply by 3 and then subtract, look what happens. Well, it still has something to do with the first term and the last term multiplied by 3, right? And there's a negative sign. What do you think I'm going to do at the very end? Divide. By what? Okay, so let's call this, this is 1. What is 3? The ratio, so 1 minus r. We've got a sub 1, right? We'll do it down here. We've got a sub 1, so I'm trying to find a geometric series. So I'd have a sub 1.
Oh, wait,
Okay, try.
Sub n equals a sub 1 minus, minus a sub n over 1 minus 1. Oh, yeah.
You're close. You're close. This term right here, how did we get here? We took it's not the total, it's if you were to take it times 3. or times the ratio, 2n. You did good. You tried, right? To get to here, you would take the ratio, take it to the power of how many numbers you have, and multiply it by the first. All over 1 minus r. You got that part. Good. It's hard, right, to derive it, but I'm trying to show you where it came from. Okay? Okay, guys, ready? You will. Okay, so let's go over all of them. Arithmetic sequence. A to the n equals what? A1 plus, no, the common difference times n minus 1. What's the geometric sequence look like? A to the n equals what? That's the series. Remember, it looks exponential. A1 times r to the n minus 1. Okay, remember? So this one's adding, this one's multiplying, correct? Okay, what about the series? S to the n equals what? There's a couple different ways to write it, right? I like n times a plus 1 plus a to the n, like the first term and the last term, and you average it. But it can be written lots of different ways, right? You have the first term plus the last term multiplied by how many there are, how many terms there are, and divide by 2. So the series S sub n is very similar to this, right? Only we're subtracting this time. So I have a sub 1 minus this guy up here, kind of, which is a sub 1 times r, but we're going to say just to the n this time, not n minus 1. We already are subtracting 1, right, by having that subtraction sign there. Does that make sense? We're adding here. I'm not even going to go there. All over 1 minus r. Questions? Yes. That's here still, right? It's the same thing. You mean this one plus, what is a sub n? It's right here, right? So you can take this and substitute it in here for a sub n if you want, right? Which would be a sub 1 plus d times n minus 1. When you add that together, you get n over 2 times 2a sub 1 plus d times n minus 1. It's just substituting in. It's the same thing as this, only you take that and you plug it in right there. Okay? Make sense? So you really only need to know these two, and then you use this one in this one if you need to. Okay? All right. It will ease your mind a little bit. The worksheet that I printed out has examples from what's on the quarterfinal that we've been doing in series and sequence. So there's 6 problems in the quarterfinal that are series and sequence. I put, I think, the front of this is series, the geometric series, the back of this I'll review. Okay? So there's a problem like that on the quarterfinal, that on the quarterfinal, that on the quarterfinal, that on the quarterfinal, one in here and one in there. So each one of the sections expect to be one like that on the quarterfinal. Make sense? Friday.
So how long?
Oh, 25 questions. I think it's 25. So 6 of them are sequence and series. Okay? I'm going to erase this. Yeah? I guess I could leave that part there. This is the one that I'm going to post online. Do you guys want me to put this here? Right here? Can go here if you want it to? Yes? No? Okay. Moving on? All right, let's work with it. You don't need this. I don't know why I put this here. This is a geometric what? Sequence. That one's a sequence. We don't need the sequence. We need the series. What's the series again? We're going to do it over and over again. S sub n equals the power of n all over 1 minus r. Okay? Okay, so let's do this one together. So put number 1 on your paper. We're doing your first homework problem right now. So what is my common ratio? Okay, I will pause. Okay, so my common ratio is -6 because -2 times -6 is positive 12. Let's check. Is 12 times -6 -72? Yes, indeed. So we know r equals -6. So if I want to find the series for 7 terms, I would put in a sub 1, which is -2 minus, what's a sub 1 again? -2, and my r? -6, holy cow, to n, which is 7, all over 1 minus -6. And this was the first problem. It's not that bad, you just have to be careful. Okay, I probably did this problem 3 times before I got it right.
Really?
Yeah, because I was making silly errors. Instead of putting r here, I was putting n, and I wasn't getting the right answer. I was being careless with my negatives, trying to go too fast. So learn from that, okay? So where should you start? No. Exponent. So you're going to want to put, believe me, you're going to want to take this slow, right? So I have -2. A negative times a negative is a positive 2 times whatever -6 to the 7th is. What's -6 to the 7th? I just want to make sure I can see it. -279,936. Did everybody get that? Now what are you going to do with that? Multiply it by 2. What do you get? I have -2 minus 559,872 all over 7. And I get -79,982. That's it? Yes. I don't suggest you do it. Don't do it. Don't do it. Why would you try and be hot shot? Okay, well, good luck with that. What did I just say earlier? I did this problem 3 times. I made errors 3 different times when I did it. Sounds like you said something.
If we let them take the test smaller and they get it wrong, then they'll learn your distance eventually. Just let them get it wrong.
You think, in theory, right?
I learned that a while ago.
Okay. Moving on. Do number 2. Okay, so r equals what? R equals 5. So S sub 7 equals -3 minus -3 times 5 to the seventh all over 1 minus 5. If you put that all in the calculator, you should get negative 58593. That's the right answer. Question? You have to be careful. I'm sorry? It's time consuming too. Alright, does anybody need me to go through this? Alright, you guys good? Moving on? There's 2 homework problems done.
How many are there?
You have to.
I was doing my problem really good, but I did not look at the homework yet.
Okay, pausing. I almost stopped my recording. That would have been scary. Okay, compare and contrast. So I've got one more thing to go over with you. So here's arithmetic sequence. Here's series. Here's geometric sequence. Here's geometric series. I've got to add this one in here, which isn't that bad because it's basically just this. Only notice, oh, I messed this up. This shouldn't be here.
What should it be?
This should be gone. Notice I don't have an n, and I've also cut the n factor out of this part of it too. You see what I mean? No? You don't see it?
No. Yeah. Okay.
We've removed the factor of having an n, having a number of terms. We're talking infinitely. What does that mean? Explain to me what that would be.
Forever.
Forever. A sequence that keeps going forever and ever and ever and ever. Well, how in the world can you find a sum of something that goes on forever? It has something to do with this right here. Think about this right here. I'm saying that the common ratio has to be less than 1 and greater than negative 1. What numbers are less than 1 and greater than negative 1? Okay. Specifically? Fractions.
No.
When you multiply by a fraction, is it getting bigger or getting smaller?
Smaller.
Smaller. So we're talking something that's getting smaller and smaller and smaller and smaller. So you can find the sum of something infinite if it's getting super, super, super microscopically small.
Wait, so we know we're right when we're answering the correct.
You know you're right when what?
Answering the correct.
No. Let me just get there. We'll get there. Okay? All right, so I'm going to start with an example that can't be summed. So look at number 9 here. I want to give you a geometric representation of this. So my first term is at negative 1, correct? My second term is at negative 3. You guys, this is important. Seriously, pay attention. So my second term is at negative 1, 2, 3. My third term's at negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. You see what's happening? It's dropping, but it's dropping at...
So going down is the negative 1,
Yeah. It's doing this. You see it? It's dropping really fast. There is no way there is no sum for this, no infinite sum. There's no way I can calculate, because if it's going infinitely, isn't that number going to get bigger? And I know it's a negative number, but it's going to get a bigger negative number and another bigger negative number and another big negative number. It's never going to stop, so how could you add something that's never going to stop like that? Well, but I can't do an infinite, I can't come up with a total. A sum is a total, right? You can't approximate something that's going into infinity. Let me show you, hold on. Let me show you the other way around. All right? Let me show you this way. What's different about this series? It's being multiplied by 1/5, right? So it's getting smaller. Guys, I need you to stop messing with papers for a second because you're missing this. Hold on. No. I don't want, just hold on a second. Let me finish my thought. I need light bulbs to go on, and I don't need any questions right now. Okay? Just look up here. Everybody's eyes up here. Okay? So, my first term is, we're going to make it a really big scale. You'll see why in a second. My first term is 1. My second term is what? 1/5. My third term is 1/1. I don't even know if I could graph that. It's too small. Do you see the difference? This is going to go in infinity, getting smaller and smaller and smaller and smaller and smaller. It's never going to hit 0. So if I were to add this up, let's add it up. Put that in a calculator. Tell me what you get. One point what? 248. I bet you if we added another 1/5 to that, what would that be? 1/125 times 1/5. 1/625?
Yes.
Right? So if you added 1/625 to this, what would you get? 2496. Do you see how it's getting, it's just we're adding by a little tiny fraction, right? If you kept going infinitely, let's check out what happens. Let's use our, it's going to be S for series, for infinite series. There's not going to be an N here because we're talking about an infinite series. S equals a to the sub 1 over 1 minus r. What is a sub 1? 1 over 1 minus, what's r? 1/5, which equals 1/4, which equals 5/4. Put that in a calculator. What's 5/4? You shouldn't even need a calculator. 1/4 is what?
1.5.
See that? You see that? The infinite series to this, no matter if you go in this direction infinitely, you're never going to get above 1.25. Yes. Infinite series. To find the infinite series, that's your equation right there. Do you guys see how close that is? Do you understand now that if I keep adding a fraction of a fraction of a fraction of a fraction, it's going to be so super tiny that it's never going to get above 1.25? So do you see the difference between why I can find an infinite sum, hold on, I can find an infinite sum if it's getting smaller and smaller and smaller. I can't find an infinite, this may be getting smaller, but it's getting smaller in big numbers, right?
Oh.
Do you see what I mean? So this, what's the next one going to be? 27 times 3. And it's going to keep getting bigger and bigger. Can you estimate how much that's going to be to infinity? No, because it's just getting huge. The numbers are just going to get huge. But you can, okay, so does this make sense? I'm going to get another paper here. So I cannot find an infinite sum if I'm going like this or like this, right? Because it's going into infinity big numbers, right? Or like this or like this. I can't find an infinite sum. You know, because numbers are getting bigger. You can't. There is no sum for this. There is no infinite sum for things that are going huge. You can, however, find infinite sums for things that are going towards the asymptote, right?
So as long as they're getting smaller.
As long as they're getting super, super small. So something like this, or like this, or like that. Anything approaching 0 is the way you would say it. Anything approaching 0 you can find the infinite sum of because it's getting so fractionally small you can come up with a total. Let's do another example.
Question. So on number 12, would that be no?
Number 12. No, hold, we aren't even there yet. Why are you jumping ahead? So number 9 is no infinite sum. That's all you say is I cannot sum that. There is no infinite sum. You give me a number like n equals 5, I could find that sum, but if you ask me to find an infinite sum, it's not possible with this one because it's getting larger and larger and larger. Make sense? Make sense? I really want you to understand why. Okay? You can't find a total of something that goes to infinity unless it's getting smaller and smaller and smaller. Okay, let's try another one. Number 10 is 1.25. It'll never get bigger than 1.25, ever. No matter how many numbers you put right here. No matter how many times you multiply something by 1/5, it's always going to stay at 1.25 or lower. Okay? Which is kind of a really abstract way to think, right? That you can add something to infinity. Really, if you think about it. All right. Number 11. What's R for number 11? 1/2 or 0.5? Okay, is this number getting smaller or getting larger? Smaller, so I can add this. So S equals A sub 1 over 1 minus R. Do that one. Not 2.25.
What?
Did you say 2.25? What did you get? No. 7? 10. Isn't that pretty amazing? I can take 5, add 2.5, add 1.25, add 0.625, add the next term, and the next term, and the next term, and the next term. As long as my common ratio is 1/2, it's cutting itself in half every time, it will never get larger than 10.
Oh, I got 10.
Only about 30 seconds after you have the answer.
Wait, is it 10 or negative?
You have to
10.
solve it to know if it's not infinite, or do
You just have to look at if it's getting smaller and smaller and smaller. See how the numbers are getting smaller? I started with 5, then I went to 2.5, then I went to 1.2.5. See how the numbers are getting smaller? Then you can't do that. Okay? Okay. What did you learn today?
Geometric
Series and
infinite series.
infinite series. Good. When is it impossible to find an infinite geometric sum? When it's getting bigger. When it's getting bigger and bigger and bigger, you can't do that. On your assignment sheet, draw a picture of an infinite series that can be found and one that does not exist. What does that mean? One that's approaching the x equals 0, right, or y equals 0. One that's approaching the x-axis and one that's going away from the x-axis? I just showed you, right? These pictures right here?
So is the one on the left the one that does not exist?
Yeah, these do not exist. You cannot take an infinite sum of anything like that.
But the one on the right?
Those are all going to, closer and closer to 0.
It's not normal.
It is in math now.
No, we had a lesson in
I know, isn't that crazy? Yes, Mitchell.
Are we ever going to get a point where it's, you define where x will equal 0? That it's y equals 0? Like for the,
You won't have to worry about that right now.
well, I'll give you later on the share.
I don't know. I have to think about that. Wait, there's one more thing that I wanted to say. Can't remember what it was. Okay, we're good.